Hi, my name is Miriam Hoffman, and today we're going to talk about odds ratios and relative risk ratios in plain English so that you can understand this a little better. I prepared this presentation with my colleagues at Buffalo State in the International Center for Studies in Creativity and Mind. We do research there too based on psychological studies dealing with risk ratios, and this type of thing didn't seem so clear cut in terms of the psychological studies we do with cognitive therapies and such. So I've done it with a different model. In every ratio, no matter what kind of thing you're studying, it's divided into 4 different sections, and we letter those A, B, C, and D. A is the people who are exposed and affected by the whatever we're studying. That would be somebody who was exposed to a disease and was also came down with it. The people in the B category are exposed and are not affected. Those are people who are come in contact with some kind of pathogen or something and don't become symptomatic over it. C, people are not exposed and are affected. Those are the people who come down with the disease somehow from a different source other than what we're studying. And D are the people who are not exposed and are also not affected by this disease. To calculate this, we divide we multiply the number who are exposed and by the number who are not exposed and not affected, and divide that by multiplying the number who are exposed and not affected by the number who are not affected and not exposed and affected, and with this formula as we come up with here. The odds ratios compare the odds of an occurrence of an outcome in relationship to the exposure to the outcome. So it's really kind of the odds that you would come down with some sort of disease after you were exposed to it. To calculate this, looking at it another way, the odds that an exposed person develops an outcome is divided by the odds that an unexposed person develops the same outcome. This will become a little more clear in our later in our example. The example I came up with was that of 100 school children in hypothetically, like say a school has 100 kids. 54 of them are exposed to what I call the M1 flu virus. That's a hypothetical airborne disease at some kind of school function, say a weekend camping trip or retreat. Over the course of this observational study, 23 of those kids, of the 54 who were exposed to this, actually come down with this M1 virus. And 2 other children who did not attend also get sick. So we divide it up this way. I'm going to move over here. 23 kids were exposed and got sick. 31 were exposed and were not sick. That's 54 of the total exposed at this function minus the 23 equals 31. 2 kids got sick and were not exposed at this particular event, and of the 100 children, 56 were not exposed. That accounts for the 56 who didn't get sick, and leaving 44 remaining. So this is another way to look at it. And to calculate this, there's a long drawn out way of doing this, which I've enumerated here, or the alternative is to do it in this simpler way, that going back here, you multiply the A by D and divide that by the result of multiplying B times C. So in relative risk ratios, we are looking at the incidence of those who were exposed divided by the incidence of those who were unexposed. So it's the relative risk, and it differs from the odds ratio. And to look at this, we look at the number of people who were exposed and got sick divided by the total number of people who were exposed. And the people who got sick but were not exposed divided by the whole number of people who were exposed. So that's how we calculate that. In this particular instance, it comes out this way. To give you a 92 relative risk ratio, that the way that these kids got affected was by when they attended this school function. So the relative risk of this was 92%. So the conclusions we can make from relative risk ratios are that it's associated with the likelihood of an outcome or a disease associated with the risk of exposure. It is the ratio of the risk of the exposed population divided by the risk of the unexposed population. These kids in this study were over 9 times more likely to have picked up this virus at school than anywhere else in the whole population. So why would you use odds ratio? Why would you use relative risk ratio? In this, in the instances of rare disease where you don't have a big pool of people to look at, and you're looking at a few cases of the disease, you can't necessarily determine the relative risk because the sample is so small. In this kind of case, where the outcome is rare, the odds ratio can approximate this sort of risk. In conclusion, I'd like to tell my friends at Buffalo State that although this whole model is based on a disease model, it's equally applicable in other circumstances that we have. Is in the bus study currently underway at SUNY Buffalo, where they're looking at a 9-frame Johari window of people who studied, who are experts at creative problem solving, people who have some exposure to creative problem solving, and people who have no exposure to creative problem solving. And then the other way they're looking at how many ideas they come up with, and I can't remember the other 2 factors, but anyway, it's a 9-frame thing. This, what we're talking about in this, is just kind of, is it like what's called a 2x2 chart. And you could do this kind of thing that they're doing with the bus study in Buffalo, in dividing up the people who've routinely been introduced but to creative problem solving, but didn't use it routine. And the people who actively use creative problem solving would be group A. The people who've been introduced but don't routinely use it would be group B. Those who instinctually use something like creative problem solving in their test, who show the skills that are available in this kind of framework, but haven't been exposed to it. And then the other one would be the people who know nothing about creative problem solving. So I use this analogy with the disease to make it clear to my HPA 472 classmates and instructor to rather than using a psychological profile, because none of the studies I've really read really exemplified this, and I thought in terms of an example, this was the best. So remember always, as we're working through our research design, whether it be in psychology, creativity, or in medicine, that practice makes perfect or nearly perfect research design. Thanks. We'll see you next time.